the harmonic conjugate of a real value function. We've seen that we have two methods, right? The first one is what? Using the partial derivatives. You using the what? Partial derivatives. While the second one is what? Milne-Thomson method. Milne-Thomson method, right? You know, for the first one, we've actually solved this same question using the partial derivatives. We've gotten the f of x, right? Meaning we've gotten the analytic function. But the way we solved that was that we found the conjugate, which was v. Then we substituted into the analytic function, meaning f of z. But by Milne-Thomson method, we are going to get the f of z directly. We are going to get the f of z directly. I told you guys that you just, for this particular method, all you need is the steps. All you need is the step. You just need the steps. Similarly for the partial derivatives, right? Now, your number one step for this particular method is what? What's your number one step? Given this question, check if this function is an harmonic function. If this function is an harmonic function, and we've seen that with the previous example we did. We've seen that this is what? An harmonic function. How do we know that it is an harmonic function? By the time we solve for the Laplace in two dimensions, meaning this equation is equals to what? 0. So we've seen that by the time we solve this, we got 0. Hence, this equation or this real value function is an harmonic function. Now, let's find the conjugate, meaning we want to substitute the given function and the conjugate to get our analytic function. But we are using Milne-Thomson method, which will enable us to find f of z directly. So I'm going to get f of z, which is equals to u as a function of x, y, plus jv as a function of x, y directly. Now, from here, what's your first step? Your first step is what? Let's do this together, please. What's your first step? You have it in your note already. So what's your first step? Differentiate u with respect to x and differentiate u with respect to y. So you are saying the partial derivative of u with respect to x is equals to what? Exponential of x cos y, right? And the partial derivative of u with respect to y is equals to what? Negative exponential raised to the power of x sin y, right? Now, from here, this is just your first step. Step 2 says that compute the partial derivative of u with respect to x minus I multiplying the partial derivative of u with respect to y. And this implies what? Substitute value. What do you have? What's the value of this? What's the value of this? Or you say, what's the expression? For this, I'm having exponential raised to the power of x cos y minus, all into bracket, minus exponential raised to the power of x sin y. Don't forget your imaginary number, right? Meaning negative I. Then by the time you solve this, it becomes exponential raised to the power of x cos y plus your imaginary part, right? Meaning exponential of x raised to the power of, meaning exponential raised to the power of x sin y. This is step 3, right? Is this step 3 or step 2? Step 3. Then step 4 says that let f of z is equals to the partial derivative of u with respect to x minus I multiplying the partial derivative of u with respect to y. By doing that, the partial derivative of z is equals to what? Exponential raised to the power of x cos y plus the imaginary part, meaning x sin y. Up to this level, your next step is what? Substitute x equals to what? Z, and y is equals to 0. Call this equation 1. So let's substitute x equals to z and y equals to 0 into equation 1. But you observe that exponential is common. So let's factorize. I'm having that f of z is equals to the exponential raised to the power of x, all into bracket cos y plus j sin y, right? So f of z equals to exponential raised to the power of z, all into bracket cos 0 plus I sin 0, right? Then you have f of z is equals to exponential raised to the power of z multiplying 1 plus I times 0. Because 0 is what? 1. Right? So you are saying f of z is equals to exponential raised to the power of z. True or false? This will give you 0. This is 0. 0 plus 1, 1. 1 times this, you have this. But z is equals to s plus jy. Therefore, f of z is equals to exponential raised to the power of x plus I. You know, I and j, you can use it interchangeably. They are imaginary numbers. Right? Up to this level, any question? No question. This is my f of z. But my f of z, I want to express it in this manner, right? Yes, sir. Right? That's what I know when it comes to analytics function. So up to this level, this is actually correct. But I want to express f of z as this, right? Now, since I didn't know that, it will take us back to indices. By indices, you are saying that a raised to the power of m times a raised to the power of n is equals to a raised to the power of m plus n. So applying that idea to this f of z, it means from equation 2, you are having f of z is equals to exponential raised to the power of x, right? Multiplying exponential raised to the power of what? Jy, or you see iy, right? You know, I'm still, the whole idea of Cauchy-Riemann is what? Complex number. By complex number, I have the rectangular form of complex number. I have the polar form of complex number. I have the what? Exponential form of complex number. Because from your complex number, the exponential form of your complex number, say exponential j theta is equals to cos theta plus I sin theta. True or false? So I'm using this. Meaning, I'm having exponential iy. It means that I can write this as what? I can write this as exponential raised to the power of x, a big bracket. What do I have? Cos y. In this case, j theta. The angle becomes what? Cos theta plus j sin theta. In this case, the angle is what? Y. So I'm having cos y plus I sin y. So I'm saying, open your big bracket, cos y plus what? I sin y. Expand this. What do you have? Exponential raised to the power of x cos y plus I exponential raised to the power of x sin y. This becomes your what? F of z. So compare this to what we did previously. Is it correlating? Yes. It is. It is correlating. Now, compare this method and the previous method. Which one do you prefer? You prefer this one. You prefer this one. You prefer that one. Anyone, your choice. Choose anyone you like. But if I'm the one to choose my method, I prefer this one. Because this is very easy. No stress. This is very easy. Straightforward. It is straightforward to the extent that step 1, implement. Step 2, implement. Up to step 7, up to the last step. Though it depends, it's just understanding. The first one too is easy. It's just understanding. So meaning that, given this question, the harmonic conjugate is what? The harmonic conjugate, meaning v of v, which is a function of x and y, is equal to the exponential of x sin y. And you can see that that was what we got when we used the other method. The difference here is that for the first method, you find the conjugate. Once you get the conjugate, you substitute into your f of z, meaning your analytic function. But for this particular method, it helps you to find f of z directly. No need of you finding conjugate, then substitute. It helps you to what? Find f of z directly, or it helps you to know f of z directly. So that's the key difference between this method and the other method. So use any method of your choice. But I advise you, whenever you want to do your exam or your test, is what your lecturer, what you have been taught in class, that's what you should use. Because if I'm your lecturer, if I'm your lecturer and you did this for me, I will wrong it for you. I'll miss it for you because that's not what I taught you. So just know it. Just know it. Just know it. Though it depends. If I'm a lecturer, I might not wrong it for you, but some lecturers are very strict. I'm lecturers.